Hello and welcome back. So we're going to talk today about the project, and I'm going to tell you a few things about how to implement the entire project. What we will be doing is we're going to be designing a connecting rod for an internal combustion engine. And I'm going to just show you a report that will guide you through the design process, and this will be online, so you could actually use this report as a guidance online. Once we go through that, then I'm going to also show you a project report that you will write yourself, but in a guided way. So let's just kind of get started here. So the project is here. It's a failure analysis of a connecting rod, and this is the project guidelines that I will cover. And let's just look at the contents. So you'll see that what we will cover here is the report. When you're finished at the end of the 10 weeks, your report is going to include load analysis, preliminary design, which you'll do using beam theory, and two-dimensional solid model in COMSOL, in which you will have constructed variants of the connecting rod and learn how to do the meshing, and then apply the loads on the connecting rod. And using the two-dimensional analysis, we will be able to do some level of optimization. So if you look at chapter 5 here on the guided report, you will learn about parameters and variables in COMSOL, how to go from one reference frame to another reference frame, and then how do you apply the loads and the constraints, and how do you set up study solvers, and then obtaining the results. Once we obtain the results from the finite element method, it will give us an idea about the stress distribution. But as we will be learning in this class, understanding stress distributions and strains in the different parts of the component is usually not necessary and not the final way that we can judge whether a component has failed. And therefore, we will have to go through a translation stage from understanding the distribution of stresses to understanding how we do failure analysis of the connecting rod. And that will get us to chapter 6, in which we will learn fatigue analysis, following what we have covered in this course. And also chapter 7, we will perform fracture analysis on the connecting rod. And finally, we will do design optimization. Having done this with 2D model, it will allow us to do very many calculations, many different geometries, different material selections, and different configuration of the geometry. Then once we have settled on a particular design from the optimization, then we will learn how to do 3D, full 3D analysis. And we'll do 3D analysis using SolidWorks first to construct a more realistic 3D configuration of the connecting rod. And the final chapter in your work is going to be on a 3D elastic finite element analysis. And we will do that either in COMSOL or in Abaqus. So it depends on how we will progress in this project. If we're going to do it in Abaqus, I think it will be an added benefit because you will learn one additional piece of software. So generally, if you look at this document, you will have it online, and the document will explain to you the elements of the project, starting from the introduction, and the introduction